So let's look at one more example of computing a weighted mean. Okay, sort of a different context. Before we get to this formula here, let's just jump into the example. So I've got a group of 130 volleyball players, and that group has an average height of 60 inches. And then I've got another group of field hockey players, there's 200 of them, and they have an average height, or that group has an average height of 55 inches. So we want to find the average height of both groups combined. So the thing to notice in this example is that we don't know the heights of any individual field hockey player or volleyball player. But we can still find the average of the combined group, and this is how you want to think about it. So let's let x bar be the average of the combined group. So here's how you can think about it. Since there's 130 volleyball players, they have that group has an average height of 60 inches. What that basically means is when you add up all their heights and divide by 130, you get 60. So if I'm going to just say sum of heights divided by 130 is equal to 60. What that means, though, is that if the sum of the heights divided by 130 is equal to 60, that means that the sum of the heights of all the volleyball players is just 60 times 130. In other words, the average times the number of players there are. Okay, so even though we don't know the individual heights, we know that we're supposed to add them all up. And we can't do that, but we can still get that total sum, because when you average, you're sort of spreading out everybody's height kind of evenly. And when you do that, you get 60 inches. That means 60 times 130 will give you that sum back. And that's all we need in order to find the average. So, again, I'll indicate here that if the 130 volleyball players, if that group has an average height of 60 inches, it's like saying, sort of in a rare case, you could imagine that everyone on the team had a height of 60 inches, right? And we'll just say there's 130 of these. Right? You can just pretend that they all had the same height, which is 60 inches. Therefore, the average would also be 60. And then we'll similarly add in the 200 field hockey players. Since their average height is 55, we can just imagine that each player has a height of 55. Okay, so just imagine it's this weird team, or it's a big team, I guess, but it's this weird group of field hockey players who all have the exact same height. You can think about it like that. So there's 200. Now we're going to divide by however many players there are. Well, there's 130 volleyball players, and there are 200 field hockey players. So this is how we'll get it. And obviously, we're not really going to add 130 times. We're just going to make use of the fact that it's the same as 130 times 60, and this is the same as 200 times 55. And we'll divide that by the 130 plus 200. So this is what we mean up here. This is what the formula really means. This says the weighted sample mean of 2 or more data sets with n1 data points. So this is our n1. And a mean for that group of x bar sub 1 x1 bar. That's what that value is. The 200 is the number of data points in the second group, and that's the second group's average. Of course, that's n1 and that's n2. So that's all the formula is saying. The idea is you want to multiply the average times the number of values there are. Do that with both groups, add them, and divide by the total number of data points. So I've done this out, and I think you get 56.97. You can check that. So 56.97 inches. Okay. You may notice that it's a little bit closer to the 50, well, that's actually a lot closer to the 55 inches, meaning the average height of the field hockey players, than it is to the 60-inch average of the volleyball players. And that's because there are more field hockey players. So they sort of have more, their average height has more weight.